Hi everyone, this video is about scope rules, closest nested scope rule and the difference between static versus dynamic. A scope is a program section of maximal size in which no bindings change, or at least in which no redeclarations are permitted. In most languages with subroutines, we open a new scope on subroutine entry. What are the things that is happen when we enter a subroutine? That is going to tell. We create bindings for a new local variables, deactive bindings for global variables that are re-declared. These variables are said to have a hole in their scope, make reference to variables. Scope can also refer to something other than subroutine call. On subroutine exit, we destroy bindings for local variables, reactivate bindings for global variables that were deactivated. In Algol 68, the process of creating bindings when entering a scope is termed as elaboration. In ADA, repopularize the term elaboration. Storage may be allocated, task entered, even exceptions propagated as a result of the elaboration of declarations. Next is static scope. Another term is lexical scope. With static scope rules, a scope is defined in terms of the physical structure of the program. Determination of scopes can be made by the compiler. All bindings for identifiers can be resolved by examining the program. Typically, we choose the most recent active bindings made at compile time. Most compiled languages, C and Pascal included, employ static scope rules. Initially, simple versions such as early BASIC had only one scope, that is, the entire program. Later distinguished between local and global languages such as Fortran. Generally speaking, a local variable only exists during the single execution of that subroutine. So the variable is recreated and reinitialized each time it enters that procedure or subroutine. Think of variables in C created in a loop and which don't exist outside the loop. Then next is overriding the static scope. C and other languages allow the coder to override this so that your value is not reinitialized each time. Next is most closely nested rule. The classical example of static scope rule is the most closely nested rule. It is used in block structured languages such as Algol 60 and Pascal. The rule is an identifier is known in the scope in which it is declared and in each enclosed scope unless it is declared in an enclosed scope. To resolve a reference to an identifier, we examine the local scope and statically enclosing scopes until a binding is found. Simply, to find object referenced by a given name, we look for a declaration of the innermost scope. If there is none, we look for the declaration in the surrounding scope. Okay, let us look at the example. This is the program in Pascal. You can see there are procedures P1, P2, P3, P4. In procedure P1, you can see a variable x is declared, and in the function f1 there is a variable x declared. In body of P3, you see body of P3. In body of P3, P3 A3, P2 A2, x of P1, P1 A1 are visible. In body of P2, P3 P2 A2, x of P1, P1 A1 are visible. In body of F1, you look that x of F1, F1 A5, P4 A4, P2 P1 A1 are visible there. In body of P4, F1 P4 A4 P2, x of P1, P1 A1 are visible. In body of P1, x of P1, P2 A2 are visible. Here we can see that the variable x declared in function F1 is visible only there. Accessing variables from another scope. In previous example, the global x is hidden during part of a subroutine because of a local variable called a hole in its scope. In the above example, the variable x declared in procedure P1 is hidden during the subroutine F1. So it is called hole in its scope. Sometimes scan can scope to a different binding. Remember, scope resolution in C++ used to get access to functions we loaded from the STL. Example, in array we can say myproc.x. In Python, self.variable. In C++, scope resolution operator x is a global variable x. This is how we can access variables from another scope. Scope rules. Note that bindings are created in a subroutine and destroyed at subroutine exit. The modules of Modula ADA give you closed scopes without the limited lifetime. Bindings to variables declared in a module are inactive outside the module, not destroyed. The same sort of effect can be achieved in many languages with own algol-term or static C-term variables. Access to non-local variables is possible. It is possible through static links. This is a question used come in previous question paper. Each frame points to the frame of the routine inside in which it was declared. In the absence of formal subroutines, correct means closest to the top of the stack. You access a variable in a scope k levels out by following a k static links and then using the known offset within the frame thus found. Here we can see the static links. Here we can see subroutine C and D is there. It is nested in B and B in A and E in A. Each frame on the stack contains a static link point to the frame of the static parent. Okay, this is how we can access a variable. Subroutine C and D is nested in B. B is the static parent of C and D and B in A and E in A. The key idea in static scope rule is that bindings are defined by the physical structure of the program. With the dynamic scope rules, bindings depend on the current state of program execution. They cannot always be resolved by examining the program because they are dependent on calling sequence. Dynamic scope rules are usually encountered in interpreted languages. Early Lisp dialects assumed dynamic scope rules. Some languages do not normally have type checking at compile time because type determination is not always possible when dynamic scope rules are in effect. Here we can see the program scopes input output. There is a variable a integer. Then procedure first you can see begin a is equal to 1 to n. Procedure second variable a integer. Begin first end. Begin a is equal to 2 second write a end. We will look what will be the output when it is static and dynamic. If static scope rules are in effect, as would be in the case of Pascal, the program prints A1. If dynamic scope rules are in effect, the program prints A2. Why the difference? At issue is whether the assignment to the variable A in procedure first changes the variable A declared in the main program or the variable A declared in the procedure second. This is the question asked in previous KTU question. I will come with the next video. Till then, bye.